we ran out of time in class to cover this part. So I hope you're picking up where we left off on your notes, okay? And this is also parametric, continuing on parametric equation, and this is 10.5. So please follow along, find this page on your notes. Now this guy looks a lot like the other guy, right? But there is something different. I want you to look at your first example that we went over, which was like this, okay? Look at the time that it started, and I want you to look at the shape of the graph, but also the orientation, okay? The path of the curve, and also the orientation, okay? Now look at this guy here. It's very similar, don't you think? Isn't it very similar? I think the path is the same, except your x and y, their functions are different in terms of t, right? Okay, and that's how I was able to come up with these coordinates here. Okay, from -1 all the way to 3 over 2. So I tried t equals -1. I used to, at t equals -2, it's here. At t equals 0, it's here. At t equals half, it's here. At t equals 1, it's here. And then finally, at t equals 3 over 2, it's over here. Now, I took 5 different times with different functions. I'm just curious, can you tell me, is it exact, what's similar about this graph and the first one? Right? Can you see the similarity between them? So some of you might say it's the shape. Okay, good. Yeah, the shape is the path is same, right? The path is the same, but also the orientation is same, right? Because this one's going from here all the way to the end, and so is this one. But let me ask you a deeper question. Okay, all right. So similarities are they are traveling in the same path, in the same direction or orientation. But who's going faster? Is one traveling faster than the other? Okay, I want you to think about that and consider that. Okay, we're going to pick up on that next time I see you, okay? Which one? The first example we did in class, or the second example here, which one is traveling faster? So I want you to ponder that, all right? And we'll discuss it when I see you, okay? All right, moving right along, let's move on to part 2. Dun, 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 okay? Now, these two, part 2 is about eliminating the parameter. This guy is x. This is exactly what x is in terms of time, or t, okay? X in terms of t, y in terms of t. Horizontal distance, maybe? I'm just giving a general, most common usage. Horizontal or distance in terms of at what time? At what time and where is it? Right? How far did it travel? At what time? How high did it travel? Or how high did it go? Right? So eliminate the parameter means we don't want t. No want t. We want x's and y's only. So keep that in mind, okay? All right, so let's do it this way. Let's do this. So you guys, do you even know what the shape of this graph looks like? Do you? Can you imagine it? I mean, if I showed you this, maybe you're going to say it's like a parabola because it's a square. But is that true for parametric? How about here? You're like, this one's linear? So you mean they're separate? But we're combining them together. So you know what I think we should do? I think the first thing we should do is we could check out the graph. So I made a table, okay, small little table of t, x, and y, okay? And I started from -2. So I have to always give you when I want you to start and how far I want you to go. So I'm going to try -2, -1, 0, 1, and 2. Okay? And here's what I get. When I plug in -2 into here, I get 0. When I plug in -2 to here, I get -1. When I plug in -1 here, I get -3. When I plug in -1 here, I get 1/2 negative. When I plug in 0 here, I get -4. When I plug in 0 here, I get 0. 1 here, -3 again. 2 here, I get 0. 1 here, I get 1/2. 2, I get a 1. So this is my parametric. Okay? Okay, so you guys, if you have a parametric, let's try sketching this guy. Okay, I'm going to try sketching this guy. I'm going to try sketching this guy from -2 to 2, and I can see my values here, okay? I'm going to go like this. I'll I'll just try to sketch, but I know I gave you guys graph paper before you guys headed out. So make sure you guys use your graph paper if you have to. Now remember, when you're graphing your x's and y's. Okay, 0, negative 1. Negative 3, oh sorry, negative 1, 2, 3, and negative half, okay? Negative 4, 0, negative 3, half, and 0, 1, okay? So it looks like I have a horizontal parabola, right? Okay, horizontal parabola. It's traveling at here, and I know I'm starting at t equals negative 2 and end at t equals 2. Okay, and remember, label everything, negative 1, t equals 0, t equals, negative 1, 0, 1, okay, and 2. Okay, that's what it looks like. And you know, if you know anything about parabolas or horizontal parabolas, that's what you should expect when we eliminate the parameter and we have it in xy term. So just keep that in mind. So this is just to keep this in mind, that whatever you get as when you eliminate the perimeter, that's what you should get. Let's try it, okay? So here is how you eliminate the parameter. I'm going to solve for t. I'm going to solve for t. Which one's easier to work with? I know what you're thinking. Maybe it doesn't matter to you because you're a smarty pants, but I think y equals half is easier. So I'm going to let t equal 2y. I use the second equation, y equals half t, to get t equals 2y. Okay, so that means everything that I see, every time I see t, I'm going to plug in for 2y instead. So now x is equal to, not t squared minus 4, but I'm going to replace that with 2y. Minus 4, so I get 4y squared minus 4 is x. Dun 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 dun, dun 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 dun. What do you notice here, you guys? Oh wait, that's a parabola with a y squared, which means it's horizontal parabola, right guys? We just did that in 10.1 for conic sections, right? So let's write this as an STD. Let's take this and write it as an STD, which means we get, we would have to isolate the y squared, right? So I'm going to go x. So I'm going to go like this, you guys. Can I do this? 4y squared is equal to x plus 4. I just swapped around the equation, and here's what I get. Y squared equals 1 over 4th x plus 4. And that's my STD of a horizontal parabola, okay? And you guys, if you were to graph this, oh wait, I'm done. I've just eliminated the parameter, eliminated the parabola. And this guy here is indeed this guy here, okay? I've eliminated, and how did you know that we're done? We're done because it's always in x and y term, okay? And if you were to take this guy and graph it in your calculator, you would indeed get the same thing as this, okay? We're going to talk about restricting the domain more in class, okay? But if I gave you only from negative 2 to 2, this is what you would end up, so you'd have to limit the domain here. But for now, let's just work on eliminating the parameter, okay? Okay, let's try another one. Ooh, I can already tell that these two are parametric and not rectangular. Our goal is to eliminate the parameter, so it's rectangular. Okay, so we want rectangular. Okay. Okay. No t's. Okay. But before we do that, I'm gonna do this again. First, let's see what these would look like. So you know what I've done, you guys? I've made a table again. And look, t, x, y. And now, here, I can see the domain, it should start at negative 1. Because here, it fails because the denominator becomes 0, so it's undefined at negative 1. Here too. Well, not really here. Negative 1 does work here, but because it has to satisfy both. This one, square root of 0, actually no, it doesn't work, right? Because negative 1 plus 1 is 0, square root of 0 is 0, but 1 divided by 0, 1 cannot do. So we're going to start from negative 1, but you know what I'm going to write? Negative 1, it doesn't work. It's undefined there. So let's go on. You know, I'm going to try some crazy values here. 0.75, but don't worry, I've already done the calculations for you. When you plug in 0.75 to this guy, you get 2, and you get negative 3 here. You get 0, t, let's try 0, 1t, and then 2 for t. And when I plug it into respective parametric equations, here's what I end up with. 1, 0, 1 over root 2, 1 over 2, and this guy is 1 over root 3, and this guy is 2 over 3. Okay? And I've already graphed this for you, and you guys, this guy, I have to specify that t has to be greater than negative 1. Domain has been restricted. The domain has been restricted. Okay? Has to start there. Okay? Okay. And then I can say that t is going to go to infinity, okay? But it's maybe greater than negative 1. Okay, so you know, when I graph this guy, you know what it looks like, you guys? I graphed this guy already. When I plugged in my 2, negative 3, 1, 0, and so forth, here's what I look like. Here's what it looks like. I'm going to go... You notice why I started at negative 0.75? Because I know that negative 1 doesn't work, but I know only negative 1 fails. Everything else will work here. Anything from 0 to 1 works, right? So it's 2, negative 3. Whoa, that's the first value, huh? Isn't that strange? And that's t equals negative 0.75. That's the first value. Let's go to 1, 0. 1, 0 is here, and that's t equals 1. Okay, I'm sorry, t equals 0. Let's go to 1 over root 2 over 1 half. So 1 over root 2 is about 1 divided by 1.41, so it's going to be smaller than 1, so maybe about here. Okay, so 1 over root 2, so it's going to be about 1 over, so it's a little bit less than 1, right? But it's going to be a half, so I'm going to go like that. Just guesstimate. We're trying to just guesstimate. This guy is t equals 1. And at t equals 2, it's going to be 1 over root 3, which is 1 over 1.73. So it's going to be, you know, just some decimal amount and 2/3. So as long as you go up 2/3, I'm okay with that. So maybe like here. So you can kind of see the path. Okay, you can kind of see the path. And you know the orientation is something like this. Okay? Everyone okay there so far? So this is what our graph should look like, okay? But I wonder if x could ever be 0. Can x be ever 0? Can this ever produce anything 0? So you know for sure it's going to be an open circle here. This is open, okay, open, until x is greater. So x has to be greater than 1 here too. Okay? We'll talk about more of the domain restrictions later, okay? All right, now what are we going to do? Well, we know what to expect. This is our expectation. So we know it's going to be like like a vertical parabola, but actually it's a vertical parabola that's only about half. So here's what we're going to do. Which equation? We're going to verify that this is going to give us a parabola that's vertical that matches this, okay? So rectangular purposes, which one is easier to mess with, right? So I'll just choose this one here, okay? So if I square that, I get this. Okay, I'm almost there. What's my goal? To solve for t, right? So I know for sure that x squared, sorry, I'm going to do this way. Okay? Remember, my goal is to solve for t, okay? So I'm going to go 1 over x squared is equal to t, 1 over x squared equals to t plus 1, okay? Okay. All right, so what does that do, okay? So t plus 1, we know it's 1 over x squared. But you know why I'm not cheating? I'm a little cheating here. I see here that y is equal to t over t plus 1. But wait, I have a t plus 1 here. So if I wanted to, I can do this. Y is going to equal t over, instead of t plus 1, I'm going to replace it with 1 over x squared. Okay? Okay. But you know, if t, right? What's t then, right? What's t then? That means t is going to equal 1 over x squared minus 1, right? So let's replace t too. 1 over x squared minus 1 all over 1 over x squared. Okay? Now what happens here? Remember our goal, now wait, this is good. So maybe somebody out there is going to say, we've eliminated the parameter. But let's make it nice and neat, right? So we can tell that it's going to be a vertical parabola. So I'm going to multiply top and the bottom by x squared. So I get, right, 1 minus x squared all over 1, which is just 1 over y equals 1 over x squared. And you guys, everyone out there, we don't need this 1, right? Everyone out there knows that this is a upside down parabola. However, this is a key thing. You guys, we're done. We've eliminated the parameter. The answer is y equals, we could write it this way too. Ooh, right? You know this matches this kind of. But wait a minute. We should only be able to see only half of it. How much? Great. What half? It's the half that's larger than 0. So we have to, we're not done here. You have to specify. You have to specify that x has to be greater than 0. And that's what I was talking about here earlier. You have to specify it, okay? In order for them to be matching. So when you eliminate the parameter, it has to match the original parametric equation. Okay? All right. I think just take it slow, okay? And on the next video, I'm going to show you this guy here. Sketch with direction, then eliminate the parameter. So same thing, what we've been doing. We first sketch it, and then I want you to eliminate the parameter, and then make sure you solve this to match this guy here. Okay? Have fun with it. Watch the next video. Bye!